Imagine a world where energy flows seamlessly, powering everything from smartphones to electric cars. At the heart of this revolution lies the lithium-ion battery, a compact powerhouse that stores and delivers energy. But how does it work? Let's dive into its inner workings. Every lithium-ion battery has three main parts: the anode, the cathode, and their electrolyte, as well as a membrane separating the anode from the cathode to prevent shorting. Their electrolyte acts as a bridge, allowing lithium ions to move between these two electrodes. Their initial chemical interaction forms a solid electrolyte interface, or SEI, that reduces excessive side reactions. When charging too fast or at low temperatures, lithium plating can form that can lead to more SEI growth and more plating, a vicious cycle that not only degrades the battery, but can lead to dendrite growth, which if large enough to pierce the separator, leading to an internal short circuit, potentially causing battery failure or even fire. But don't worry, in future episodes, we will describe how BMS electronics can help monitor and protect lithium-ion batteries from overcharging and other dangerous conditions. Lithium-ion batteries comes in different form factors: cylindrical cell, typically used in laptops, power tools, and electric vehicles; prismatic cells, commonly used in electric vehicles and energy storage systems; and pouch cells, used in smartphones, tablets, drones, and some electric vehicles; and coin cells, commonly used in medical devices, watches, and sensors. Now let us learn how these batteries are made. The first step in cylindrical cell manufacturing is electrode coating, where cathode and anode materials are coated onto aluminum and copper foils. Then comes the drying and slitting step, where the coated foils are dried and slit into strips. Then the electrode sheets are rolled into a cylindrical shape with a separator in between, and then placed in a steel or aluminum casing, and electrolyte is injected. Finally, the cell is sealed, charged, and aged for performance stabilization. Prismatic cells manufacturing process is similar to that of cylindrical cells, except the foils are wrapped into rectangular shape and then housed in metal casing. Finally, the cells are sealed, stacked, and charged. Pouch cells manufacturing process is similar to that of prismatic cells, except the electrodes are stacked rather than rolled, and the pouch cells are housed in flexible aluminum plastic laminate rather than metal casing. Coin cells manufacturing process also coats cathode and anode materials onto metal foils and then punched out in circular patterns for assembly. During the assembly process, a small amount of electrolyte is deposited between the electrodes along with a membrane. Then the entire assembly is crimped and sealed. That is how lithium-ion batteries are made. The next time you use your battery-powered device, remember all the engineering and manufacturing processes that made it all possible. Thank you for watching this video.